In this video, we're going to begin the study of biology, modern biology, and my intention of offering this course is to provide students in the Classical Liberal Arts Academy with the opportunity to satisfy modern high school science requirements, but to do so in a way that allows them to apply what they learn and what we teach in classical philosophy and Catholic theology to the study of modern biology. In this course, we're going to use a biology textbook that's well respected, even though it's a little bit older than a modern textbook, and we're going to do that for a few reasons. First of all, the content of the modern sciences, despite all the talk of constant innovation and research and this and that, the content of these sciences really doesn't change very much through the years. From the development and explosion of the modern sciences in the 1600s, through the 17 and 1800s and into the 1900s, there really isn't a lot of information to learn that's new year by year. The reason why is because modern science is actually the result of an idea in philosophy. And once that philosophy works itself out, it creates the knowledge that flows from it. And once that knowledge has been created, that's produced by this modern philosophy, that content's really not going to change much. It's really not dependent on research and the results of experiments and so on. It's really the result of a philosophical system that I'll talk about here and there as we go through the study, and it really doesn't change as much as people like to pretend it does. One of the reasons why there's always pressure on having the newest textbook is not because the content is changing, but because it makes the publishers and authors more money. And so we're going to go back a bit to a quality biology textbook that I think will be very helpful. Another reason why it's good to use older books is because the older scientists were a little more honest in the way that they spoke about science. They were more honest when it comes to admitting that certain things, certain ideas are mere theories, that they're not proven facts, but they're theories. And it's good for us to know when we're studying something that's a proven fact and when we're studying something that's merely a theory or a teaching based on other assumptions. We want to know what those assumptions are and whether or not we can grant those assumptions. So I'm going to try to lead students in the Classical Liberal Arts Academy through the study of modern biology, but to do so in a critical way, with Catholic theology and classical philosophy guiding and enlightening our study. All right, so let's begin. I'd like to read through the text for you and with you to help you get through this first reading. I'll make a few comments as we go along, and then I'm going to leave you to study the chapter for mastery and complete your lesson assessment. So let's read this first lesson in our study of modern biology. The first part of this study, as is labeled on the top of the textbook page, is botany, or the study of plant life. All right, so part one, botany. This first lesson is an introduction to the study of biology. Science deals with that material which occupies all the space around us. Science deals with that material which occupies all the space around us. And just to make it clear, what our textbook is telling us is that what we mean by science in a modern natural science class, what we mean by science is simply the study of material things, the study of material or physical objects. And so, to put this in philosophical terms, we're going to study in science, in modern science, we're going to study what are called primary substances. Primary substances, things that we can actually see, touch, taste, hear, smell, and so on. So science only deals with the material that occupies the space around us. Science cannot tell us anything about spiritual things, cannot tell us anything about invisible or insensible things. It only can speak of material, physical things. And when we think about that, we have to think about how limited this science is going to be. For us as Christians, it's only going to help us gain knowledge of material things. If we find scientists talking about things that are not material, such as the origin of the world, or whether or not God exists, or whether or not angels exist, or whether or not we have souls, if we find so-called scientists talking about any of these things, those men are talking outside of the realm of science, and they should be given no respect because they're scientists, because science has nothing to do with anything that's not material. Science deals with that material which occupies the space around us, the air, the water, and the earth. This material is called matter. Matter, it simply means material. Matter. Matter is the building material of the world in which we live. Matter exists in two distinct states. Matter may be living or may have been alive at some previous time, in which case we speak of it as organic matter. Organic matter is matter that is living or has at some time been alive. Or it may have never been alive. The latter state of matter is called inorganic. So there are two types of matter, two distinct states of matter. There is organic matter and inorganic matter. Note that dead matter is not inorganic matter. So, for example, the body of a dead animal or a dead plant is not inorganic because it was once living. It's organic matter. Inorganic matter is matter that has never lived. So a stone, for example, would be inorganic matter. We find two groups of sciences which deal with matter. Biological sciences, which treat of living matter, and chemical and physical sciences, which deal chiefly with inorganic matter. So you should know what matter is, what the two states of matter are, and what two divisions of modern sciences deal with these two kinds of matter. Biology deals with living or organic matter, and then chemistry and physics deal chiefly with inorganic matter. That's true through high school, but normally when you get further advanced in chemistry, you'll deal with what's called organic chemistry, the chemistry of organic matter. Then in our textbook we have a definition for biology, which is our study in this course. Biology is the science which treats of matter in a living state. Biology is the science which treats of matter in a living state. The two subdivisions of biology, dealing with plant life and animal life, respectively, are called botany and zoology. So botany and zoology are two divisions of biology. Botany is the study of plants, and zoology is the study of animals. All right, two divisions of biology. Biology is the science which treats of matter in a living state. And just so you know a little bit about the name, biology in Greek, the word bios means life, and logos refers to the study of something. So biology means simply the study of life. The next section is titled Knowledge in Science is Gained by Observation, and this is another important point. Knowledge in science is gained by observation. Knowledge in science should not come from philosophy. It should not come from religious beliefs. We should not need to make assumptions in science. It's one thing to propose a theory, as we'll learn more about the scientific method. We can propose a theory to guess, to take what's called an educated guess about the solution of some problem. We can take a guess, but then we test that guess with experiments by observation. And so science should never speak. If we're talking about true science, science should never speak about things that cannot be observed or have not been observed. We shouldn't be asked to make assumptions. We shouldn't be asked to grant the truth of theories. We shouldn't be asked to believe certain things about the world, things that cannot be observed. And we'll find in modern circles that science very rarely sticks to its true material. Scientists very rarely stick to science as it's described in the textbook. Science, the knowledge in science is gained by observation, and therefore a person who claims to be a scientist should never be talking as a scientist about anything that cannot be observed or demonstrated by observation. So in science, seeing is believing. In science, seeing or perceiving is believing. Science has been defined as, quote, knowledge gained by exact observation and correct thinking. First of all, science is a kind of knowledge. It is accurate or certain knowledge. The reason why it's accurate and certain is because it's based on observation. It's clear and presented to the senses. It's accurate knowledge. But it is possible to acquire a mass of knowledge that is not scientific with the aid of a textbook or a book in general. It's possible to acquire a mass of knowledge that is not scientific in this modern sense with the sole aid of a textbook, for example, in our studies in philosophy or grammar or arithmetic. We learn a great deal simply by the assistance of a textbook. Such knowledge might be that of Latin or the German language. Scientific knowledge, according to our definition in this textbook, must be gained through observation. And remember, as we go through these studies and as we talk about the natural sciences, we have to hold the scientists accountable to these statements and definitions that we learn early on in our study of science. Scientific knowledge is accurate knowledge and must be gained through observation from the accurate study of a specimen or some subject of our study, something that we may see and touch. Something that we may see and touch. It is not enough to study a book alone in science. This may be an aid, but the specimen is, after all, the main thing. If we were to fit ourselves for the trade of a plumber or a carpenter or a mason, we certainly should not depend upon a book for our information regarding our particular trade. We should instead go to the shop and there learn to work with the tools of our trade. So, in the pursuit of scientific work, we must learn to use the tools with which nature has provided us: our hands, our eyes, and the thinking mechanism, our brains. As a famous naturalist once said, study nature, not books. Now, as I said, we have to keep scientists accountable to what they say, what they claim when we begin the study of the natural sciences. We're being told that scientific knowledge is based on observation. What matters is the specimen, something our eyes and hands can perceive. But notice how we start to slide into a problem here. Notice what he says. We must learn to use the tools with which nature has provided us. Our hands, okay, that's observation. Our eyes, very good. But then it says, and the thinking mechanism, our brains. This is where science gets dangerous. The minute we move away from observation and start dealing just with ideas, we're no longer dealing with scientific knowledge. And we need to be careful, because what the scientists do is they begin speaking about observation and the senses and so on, but we'll find them quickly moving into other areas that are not observed, for which we do not have accurate knowledge. And yet they'll speak of those ideas with the same confidence and certainty that they speak about simple, observed knowledge. And we can't allow this. We have to keep science accountable to the limits of science. Science is the study of primary substances, the study of material things that can be observed by our senses. And we need to make sure that scientists and any so-called teaching about science is limited to material things which are able to be observed by us. Going on. The knowledge that we gain by observation is worth very little to us or to anyone else unless we use our brains to classify it and apply it. We must find out what different facts mean as related to one another. Again, here we start to see where science runs off the tracks. If students do not study classical reasoning, classical grammar, classical philosophy, theology, and so on, what does it mean to use our brains? What does that mean? Does using our brains mean making sure that we follow the rules of the art of reasoning and of grammar and so on? Is that what it means to use our brains? If so, then science must be subject to the classical liberal arts and to philosophy and theology. If we must use our brains, if we must think and draw conclusions based on our observations, then we would have to know reasoning first so that we can use our brains, so to speak, in the study of material things. If we have students that don't study reasoning, that don't learn to make sure that they use their brains rightly, what's going to be the value of this quote-unquote scientific knowledge? What if the conclusions are not reasonable? What if the conclusions are not true? Who's going to hold scientific thinkers accountable to sound reasoning or sound philosophy? We really can't enter into the study of science or the pursuit of scientific knowledge unless we first study and learn the classical liberal arts. And that's why, if you're interested in scientific work, scientific studies, you need to see that your diligent study of the classical liberal arts, of classical philosophy, and Catholic theology will prepare you for the thinking work that's going to be needed in science. And I'm going to argue in advance that much of what is said in the name of science is impossible because it's based on false reasoning and false conclusions, as we'll see as we go through our studies. So the knowledge that we gain by observation is not the end of our scientific knowledge, and this is where we get into trouble. It is worth very little to us or anyone else unless we can, quote-unquote, use our brains, whatever that means, to classify that knowledge and apply it. In other words, to interpret what we observe. So there's a work of interpretation and application of this knowledge gained by observation. And I'm going to argue and warn you that this is where problems come in. And Catholics need to be very careful that they don't admit false classifications and false applications of scientific knowledge. Single isolated facts about the color, coats, or markings found on the coats of a kidney bean mean but little to us if we cannot correlate these observations with other observations and relate them to scientific truths that have already been learned. So we're correlating things we observe today with scientific truths already learned. Now, what are scientific truths? Scientific truths are not theories. Scientific truths are not assumptions, beliefs, and so on. For something to be a scientific truth, it would have to be something that has been and can be observed. And again, this is where we have to be very careful. The study of modern science can be very helpful if we keep it in its place and we keep science accountable to the definitions and limits of science. A great many men working for long periods of time have gathered together a large number of single, isolated facts, have correlated these facts, and then have given to the world discoveries of worldwide importance. So again, you see what this is saying. We're no longer talking about simple scientific knowledge that's observed in material things around us. We're talking about correlations made by men around the world working for long periods of time who have drawn conclusions about this information and have passed that information based on their conclusions down to us. They have made, quote unquote, or they have given to the world discoveries of worldwide importance. A careful boy or girl may, by his own painstaking work in science, find out some fact that is new, and in a small way make a discovery. It is one of the most interesting things about science work, that it has in it the spirit of discovery. Next, the next section is titled Morphology. Morphology. It is evident that in order to understand the cause of the regular movements of a clock, it would be necessary to take the wheels apart and to find out the structure of the different pieces composing the works, so as to see how these parts are related to each other. So if we want to understand how a clock works, which is a machine, we can take it apart, or that's what's called analyzing it. We can analyze it, we can take it apart, study the parts and how they work, and then put them back together, which is called synthesis. and understand how the whole machine works. All right? In the study of biology, it is usually found best to begin with the study of the form and structure of the parts of an organism. And this study of the form and parts, or the form and structure of the parts of an organism, this study is called morphology. Morphology. All right, in the study of biology, it is usually found best to begin with the study of the form and structure of the parts of an organism. An organism is simply a living thing. This study is called morphology. Next, physiology. After we have discovered in the clock the form and structure of the different wheels and cogs and the relation of one to the other, we're in a position to put them together again and find out how they move and what causes this movement. Remember, I said taking apart is called analysis, putting back together is called synthesis. We wish to study the use or function of each part when we put it back together as a whole. The study of the uses or functions of the parts of an organism is called physiology. So morphology has to do with form and structure of the parts of an organism. Physiology has to do with the functions of the parts of an organism. Okay? So two different divisions of biology. Morphology, the study of the form or shape and structure of the parts of an organism, and then physiology, the study of the function of those parts. Next, in order to study physiology, and indeed most sciences, we frequently have to make use of an experiment. There are always 3 steps in a complete experiment. Now remember, science is going to make claims and state rules about science. We have to hold them accountable to these rules. We're told there are always 3 steps in a complete experiment. Beginners in scientific study should always try to follow these steps exactly. So what are these 3 steps of a complete scientific experiment? First comes actually making the experiment. This includes collecting and putting together such materials as we may need, a statement of the work we perform, and most important of all, a definite statement of the problem that we are attempting to solve. So the first step is basically preparing the experiment. We're going to state a problem, and we're going to gather the materials together that we need to try and solve this problem. We're going to state a specific problem. Step 1. Step 2. The second step is to make observations on the experiment which we have set up. To make observations of the experiment. These observations may extend over a period of several days or even weeks, but there's no reason why there's any such time limit. What if it was several years or several centuries? Okay. So the second step is to make observations. They must be noted in such form that we can use them in the third step of the experiment. So step 1 is to prepare the experiment, to identify the problem, and arrange what's necessary for an experiment, to seek a solution to the problem. The second step is to make observations based on the experiment, and to make sure that we record those observations in some way. The third step, the hardest step of all, consists in drawing conclusions from the observations we have previously made. Every experiment should be illustrated with drawings, or in our generation, pictures, to show all the apparatus used at each stage of the process. So step one is to identify a problem and prepare an experiment through which we seek to find the answer to that problem or solution. The second step is to run the experiment, make observations, and record those observations. And then the third step, which introduces us to a problem, is to draw conclusions from our observations, from our experiment. Now again, what we see here is that science, and this is called the scientific method. This is sort of a simplified version of what's called the scientific method. What we see here is step one sounds like science. Step two sounds like science, observation, and so on. But step three asks students to do something that isn't natural to us. We can draw false conclusions. And so we see that science isn't so simple. The work of science and the scientific method assumes something that it doesn't teach. It assumes that there's a right way to draw conclusions. But drawing conclusions is the work of reasoning. And if you look at modern schools, they have math classes and science labs and do science experiments, but they don't teach reasoning. So how do we know that we're drawing true conclusions in our experiments? If we don't study the art of reasoning, we don't know if we're drawing true conclusions in our experiments. If we look out at the world of scientists and researchers and so on, and we find generations of men and women who have never studied the art of reasoning, are we sure that they even know how to draw conclusions from their experiments and observations? We don't. And this is, again, one of the problems of science. Science, true science, takes the study and knowledge of the classical liberal arts for granted. And in the past, the great scientists were men who were educated in the classical liberal arts, and then they used their knowledge of the classical liberal arts in their scientific work. But in modern circles, this isn't true. Modern schools don't teach reasoning. They don't teach the true art of reasoning. They don't study Aristotle's organon, or the instrument, which is where we learn the art of reasoning. And so if we don't study and prove that we actually know how to draw conclusions, how can we participate in this scientific method? Do you know how to draw conclusions based on experiments and observations? Do you make mistakes and errors in drawing conclusions? Do you make false arguments? The drawing of conclusions is the whole work of this scientific method. As we said, or as the author said, collection of information, observing things and gathering facts is really of very little use unless we can complete step 3, which is the drawing of conclusions, which assumes that we're skilled in the art of reasoning. And most students in modern circles, most adults in modern circles, never study the art of reasoning. And I'll propose that this is a major problem in real scientific experimentation. And so if you would like to be a real scientist, what you see is you're going to need to be an expert in reasoning. And that's why classical studies are not contradictory or hindrances to scientific study and work. In fact, they're necessary. They're assumed by the scientific method, and yet they're not taught in modern schools. By studying the classical liberal arts, you can actually be qualified and skilled to draw these conclusions and solve problems through experimentation. There's one other problem that needs to be mentioned before we continue in this chapter, because the rest of the chapter just gets into some practical details. The kind of reasoning that we do in science is called inductive reasoning. Inductive reasoning. What we do in inductive reasoning is we observe individual things. We observe individual material objects through experimentation. And then we try to draw conclusions that are based on those observations. But there's a great problem with inductive reasoning. Just think about it. If you were to see 3, let's say, Lamborghini sports cars in your town on the road, and all of them were red, and you said, based on my observation, Lamborghinis are red sports cars, your conclusion would be false, even though it followed, or appears to follow, from your observation. You observed 3 Lamborghinis, they were all red, and therefore you drew the conclusion that Lamborghinis are red sports cars. The problem is that there are other Lamborghinis in the world that you did not observe. And so your inductive conclusion that all Lamborghinis are red is a false conclusion. When we use inductive reasoning, we have 2 options. We can either make a particular conclusion. So if you saw 3 Lamborghinis and they were all red, and you knew that there was a possibility that there were more Lamborghinis in the world which you were not able to observe, the most that you can conclude, the most that you can say based on your observation is that some Lamborghinis are red sports cars. Some. And in reasoning, that's called a particular statement. So the most that you can say, if there's a possibility that other examples exist, or other observations or specimens are possible and exist, which you did not observe, then the most that you can conclude is a particular statement. And a particular statement isn't of very great value in reasoning. The only way in inductive reasoning that you can make a universal statement and say all these things are such and such, the only way that you can make a universal statement with inductive reasoning, true inductive reasoning, is to observe all examples and find that what you're asserting of them is true of all of them. There are others in the world of which your conclusion might not be true. And so it's almost impossible, really it is impossible in almost all cases, to make any universal conclusion, to state something about an entire class of things based on inductive reasoning or the scientific method. And yet we'll find scientists doing this all the time, making broad general conclusions based on limited inductive or scientific experiments and observations, and we can't allow them to do that. That's actually false reasoning or sophistry. To make a universal statement based on a limited number of observations is sophistry. That's false reasoning. Okay, that's called a hasty generalization. We have to make sure that scientists in most cases stick to particular conclusions. And then, as we'll see, particular conclusions are rarely helpful, because you can't draw other conclusions from particular statements. Okay? So we see, and what I'd like to emphasize is that the scientific method depends on reasoning and is itself a certain kind of reasoning. A certain kind of reasoning that's very limited in its usefulness. And so, for all the things that people claim that science can do for us, it's actually largely false, because science really can't do the things that we imagine it can do without making assumptions and false leaps to generalized conclusions that it really hasn't observed and cannot prove. And most people don't keep science accountable to its own definition of itself and what it can and can't do. We allow scientists and science in general to tell us things and make conclusions that it hasn't in fact proven or observed in the way that it pretends to have observed them. They're simply philosophical statements or even religious beliefs, and not scientific facts at all. On the other hand, in the classical liberal arts and in classical philosophy, what we focus on is called deductive reasoning. Deductive reasoning is the reasoning of philosophy. And in deductive reasoning, we don't seek to learn about classes of things by observation of individuals. We don't seek to learn about classes of things by the observation of individuals. We seek to learn about classes of things by reasoning itself, by deductive reasoning. We reason from universal truths that are self-evident, that need no proof. And there are many axioms or self-evident truths. For example, we know that a part is always less than a whole. That's always true, and it needs no proof. It's self-evident and obvious. Once we know that truth, once we think about that truth, that all parts are less than the whole, we can then use that universal statement to draw other conclusions. And those conclusions are important because they are just as true as the axiom itself, as the universal self-evident truth itself. And so we can build a body of absolutely certain philosophical knowledge by reasoning, by deductive reasoning, by first stating something that's true about a whole class of things, and then applying that knowledge to every individual within that class by the definition of the thing itself. Okay, so for example, if we say that man is a rational animal, and we know that by philosophy or by divine revelation, so we go beyond the limits of what is material or can be observed. If God speaks to us and tells us that he created man in his own image, that he made man a rational animal with a soul, we know that that's true of the entire class of men. It's a universal. All men are rational animals. And therefore, if I meet a human being, any person, I can point to that individual person and I can reason deductively from what's known universally down to that individual, and I can say, you, for example, you student, are a rational animal. And I can be absolutely certain that that's true because of what it means to be a man and what a man is. And we know that by divine revelation. Now, if you're going to deny divine revelation in the name of science, How does science prove that we have a right to deny divine revelation? You have to make that assumption without any scientific proof that requires you to make that assumption. And therefore telling people that you're not allowed to make conclusions based on divine revelation is not scientific. That's not scientific. No scientist has any right to say that. All the scientist can do is show us what can be observed in the material world. He has no right to tell us whether there's a God or whether there is any divine revelation or whether God has revealed truths to us that are absolutely certain. The scientist can't tell us anything about spiritual realities or invisible beings. And when scientists speak of those things, they're not speaking as scientists. They're just making religious statements or philosophical statements, and that has nothing to do with science. We do not need to abandon divine revelation or the authority of the church or the teachings of history's great philosophers before we begin the study of science. We don't need to do that. We can bring our religion and our reasoning and our philosophy and our knowledge of the classical liberal arts. We can bring all of that in to our scientific experimentation as Christians, and we can draw conclusions about our observations based on our religious beliefs, based on our philosophical beliefs. That's perfectly scientific, as long as those conclusions take into consideration what can be observed in the material world. And so we don't need to check religion at the door, and any scientist who says that is simply speaking out of order, because he has no authority to talk about such things as a scientist. All he has authority to talk about is what can be observed. If something can't be observed, the scientist has no authority to say that it doesn't exist. All that he can say is that he didn't observe it. And he should limit his speech to what he can actually say scientifically. All that he can say is that he has not observed it. And you can see very easily how ridiculous it would be to pretend that because you didn't observe something, that it cannot possibly be true. That's just ridiculous. And much of the things that scientists say are ridiculous. Science is the study of the material objects around us in the world. It's studied by means of observation with the senses. And we must draw conclusions based on what we see, but no one has the right to tell us what information may be used in the drawing of those conclusions. And so we can build a Christian science, a Catholic science, conduct our experiments as Catholics, and allow divine revelation and philosophical knowledge to enter in and help us in drawing meaningful conclusions as Catholics. And no one, in the name of science, can tell us that we can't do that. It's perfectly reasonable, because we have to reason anyway. So we have to admit something in that's not quote-unquote scientific. We have to admit the art of reasoning. And once we get into that discussion and that study, we're going to find that we need to admit all kinds of things that are not scientific. So it's perfectly right and just for Catholic students to bring what's known about God and what God has revealed to us about the natural world into our scientific experimentation, and allow that knowledge to enlighten and direct the conclusions that we draw from our observation of material things in the world. Okay? So you should understand the difference between inductive and deductive reasoning. If anyone suggests that we may only use inductive reasoning, they deny the third step of this scientific method, which requires that we draw conclusions. That's inductive reasoning. And yet it assumes the knowledge of reasoning in general. And to say that we're not allowed to use any deductive reasoning is simply not scientific. All right? Now, to finish up, the lesson talks about some specifics, some practical details about the work of scientific experimentation. And some of this stuff is dated, meaning that when this textbook was written, this was true. And in our generation, at this present time, we can do things the way the textbook tells us. It's perfectly fine. But we also have other tools and ways and resources that allow us to do this. For example, the book talks about the use of a notebook. And it's true. We can use a notebook to record all of our experiments and observations. We can draw pictures and so on. When I was in college, we used notebooks. We had scientific lab notebooks, and we had to write out all of our experiments and observations, and all of the form of the scientific method had to be written out in notebooks and kept and submitted for grading to our teachers. Drawing, it gives some information about drawing, what kind of pencils to use, how to make drawings and stuff. And so, again, we see that the art of drawing becomes very helpful to anyone who wishes to work in science. So it leads us to realize that another art, the study of the humanities and drawing and fine arts, is useful in the pursuit of scientific knowledge. We can't just be these nerdy laboratory scientists because other skills are necessary. So we could use drawing to help us record our observations. Now, of course, in our generation, we have tools that make this even better. For example, we can take a mobile phone that's got a camera built into it, and we can take snapshots and videos. We can record audio and so on. So the phones give us even more powerful tools for recording our observations and experiments. We can also use computers and so on. Then we learn about the laboratory. And all a laboratory is a room that's designed to allow us to perform experiments conveniently. So, for example, it would provide us with water. It would provide us with burners for heating things. It would provide us with refrigerators for refrigerating things, scales for measuring the mass and weight of different objects. It would provide us with a place, basically a workshop for experiments, where all of the normal tools and resources that we need for experiments are kept for the sake of the work of the scientific method. That's what a laboratory is. Now, you can create your own laboratory at home just by collecting the tools and resources that are needed for experiments. You can do it in the house. You could do it in a garage or in a barn, and just have a place where you can conduct an experiment, a scientific experiment, where you have the tools and supplies and can control the conditions in some ways. You know, if you want to test something in a heated environment or in a cold environment, you would need ways to control those environments for the sake of testing. And that's the purpose of a laboratory. But working at home or doing experiments privately, you can create your own laboratory if necessary, or just conduct your experiments in the natural environment. Remember, again, this is like a contradiction in the book, because we're told that we shouldn't study books, we should study nature. Well, if we should study nature, nature is out here. Nature is not in a laboratory. And so just as it's false to say that we should study nature in a book, I would argue that it's just as false to say that we should study nature in a laboratory. If we're going to study nature, let's study nature. It's right out here. And so we could make an argument that the idea of the laboratory in scientific research and experimentation is actually a contradiction of the principle that this opening chapter taught us, which is that scientific knowledge should be gained from specimens and from studying nature itself, and not from studying in an artificial, separated environment like a book or like a laboratory. All right, talks about instruments that are used, and again, some of these things change over time. Microscopes that are available to us for an affordable price, back when I was in college, might have been unaffordable. They might have been hundreds and hundreds of dollars, and you can now get them for $50 from Amazon or some modern store. So the instruments used, they'll always be changing, and you should just look around and see what common instruments and tools are used today and available at the best prices. In this textbook, we'll often see things referred to that are outdated, and we'll just make some updates to those things, but it's not a big deal. And then lastly, the last point that the chapter makes is that you have to be interested in laboratory work. I'll read this last paragraph. It is not the laboratory or the equipment that makes the laboratory work a success. It is rather the spirit of the pupils or the students. Interest in the work is the first essential. When at work on what may seem to be only dry details, look ahead and think about what you're doing. Think about the end of the research that you're doing. Try to find a purpose in everything that you do. It's possible to make any piece of biological work interesting by keeping in mind that everything in nature is part of a great plan and has a purpose. Again, that's not scientific talk. You see how the scientists will do this? They started the lesson telling us that scientific knowledge is that which can be observed. And yet, look at this conclusion. Look at this statement in the book. Keep in mind that everything in nature is part of a great plan and has a purpose. How can any scientist say that? That's an example of the self-contradiction that we'll find all through science. If all that we're allowed to do is observe material things, there's no proof at all that there's any great plan. There's no way to prove that there's a great plan. And if there is such a plan, where does it exist? Where does it come from? How do we know the plan? And so this is an example again of the sloppiness of scientific talk. And we'll constantly find scientists, people who claim to be scientists, saying one thing and doing something else. Anyway, you see the point that the writer is making. And as Christians, we can applaud that, because we can say, that's right. Nature is a part of a great plan. And we know that the maker of this natural world is God, and His will and our salvation is that plan. We can bring our religious beliefs, our philosophical ideas, into scientific experimentation, just like this author did in that paragraph. And we have the right to propose what we believe that great plan is, and we have the right to propose what we believe is the purpose of every individual thing based on our knowledge of that great plan. The scientist, though, the materialist scientist, he has no right to talk about any great plan. And so there's a contradiction. To finish up, it is your place to find out just how the given part that you may be studying is fitted or adapted to its work in the general plan. So we can't even get through one chapter of this textbook without finding ourselves faced with contradictions by scientists. This is the danger of modern science that I warned you before we even started reading. When scientists talk at the beginning, everything sounds great. We're going to observe material things, and we're going to draw conclusions based on our observations. Great. That's great. But science never stays there. It always strays into other fields. And if we're going to be honest in science, and we need to keep scientists honest and keep them strictly to observations based on material objects. And we need proof, not only that they have in fact made these observations, because without observations there is no scientific knowledge, no matter what we think. And not only do they need to prove their observations exist, but we also need to test and make sure that the conclusions drawn from those observations are valid and true. And to do that, we need to use the art of reasoning. We also need to make sure we don't allow scientists to slip ideas in like this, that there's some kind of general plan that's self-evident to us, that we can talk about as if everyone knows it. No, that's part of the question, is what is the general plan? And science has no way of answering that question, because it can make no universal statements. So, I hope that's a helpful guide through this first lesson in modern biology. As I said, I have great respect for the natural sciences. I was a science major in college. I worked in a chemistry lab when I was in college. I live on a farm. I love nature. I love the study of nature. I highly value the modern sciences. But what I object to is the fact that scientists claim that we're going to limit our talk to observations of material things, and they themselves don't do that. As a Christian, I know that I have the right to bring my religious faith, to bring the knowledge of divine revelation, to bring philosophical truths and so on into my scientific study and research and observation to help me draw conclusions. The Psalms say, in thy light, in God's light, we see light. We're able to understand and draw conclusions because of the knowledge we have of God and the knowledge of the world that God has revealed to us. And we are certainly to bring that knowledge into our work in science and observation to draw valid conclusions. Scientists, anti-Christian scientists, will often object when we do that, and yet they do the same thing. And we need to make sure that we either stick to our agreement to speak only of the observation of material things, which would be a very useless study, or if we're going to start drawing conclusions, just be honest and admit the assumptions that we bring into our conclusions. For me, as a Catholic, I bring the Catholic faith into my conclusions. I bring Aristotelian philosophy into my conclusions, and join that together with my observations of the natural world to seek wisdom of material things through scientific observation and the use of the scientific method. The benefits of the scientific method, when we're honest, are very limited. Very, very limited. But nevertheless, they're helpful. And as we go through this course, I'll try to make use of the farm and examples on the farm to show you how these scientific lessons and studies do in fact help us as Catholics in practical ways. So I hope that's a helpful introduction. Study this first chapter on your own, complete the lesson assessment, and we'll move on in our study of biology as we get started with all of the natural sciences in the Classical Liberal Arts Academy. God bless your studies.